Hello and welcome to this new ABI Labs video. My name is William Santos and I'm the head of sales and marketing at ABI Electronics here in the UK. For those unfamiliar with ABI Labs, we created this series to help our customers make the most out of their ABI product. In Series 1 of ABI Labs, we spoke about the top power-off and safe troubleshooting tests that you can run with the Boardmaster. In Series 2, we powered up our circuit board and ran a number of in-circuit digital functional tests, and in Series 3, we focused on testing analog components and using the powerful set of virtual instruments to automate measurements and more complex tasks. Just a few months ago, Munib showed us how to make use of the new test flow reporting feature, another unmatched Boardmaster capability implemented by ABI engineers in 2021 for enhanced traceability and compliance of tests and repairs carried out by our customers. We'd like to thank all of you for following and watching ABI Labs so far, and also thanks for all the feedback that you have been sending over the last few months. Just a few months ago, we received a great feedback that you can see on your screen from a UK-based defense contractor. And just a few days ago, we received this amazing feedback from a biomedical company in America. In the next couple of episodes of ABI Labs, we'll be diving into another system that complements the Boardmaster. So I have Munib Ahmed with me here, and so Munib, tell us what we have here.
Hello William, so this is ABI's popular schematic learning system, and it helps people in charge of sustainment and management to generate schematics in-house.
Wow, sounds amazing, and I'm pretty sure there are people watching this at home and thinking, it sounds too good to be true, Munib.
I know, when people first hear about RevEng, that's what they think, but there's no catch, it's just straightforward British engineering at its best.
So, how does it work in general terms?
Sure, so RevEng has up to 2048 channels in total, and it allows personnel, technicians and engineers to connect to different entities on the board. So whether that's the edge connector, discrete components, ICs, any type of connector component, it allows you to connect and interface with that. And the system basically runs a continuity test, learning all of the connections on that specific PCB, and then it generates a netlist. So the netlist contains a list of all the components and their relative connections. So once this has been generated, you can then import this into a professional CAD software, and then following that, you can then generate the schematic.
It sounds very, very interesting. It actually brings back memories because I recall visiting a large hydropower plant in Brazil a few years ago. And I was visiting the maintenance department in that power plant, and they brought one of the PCBs that they were attempting to reverse engineer by hand. So using the traditional method, the pen, the paper and the multimeter. And the technician actually told me that everything going well, they would finish that work in about 5 to 6 weeks. Comparing to RevEng, how would you say that the process would be able to be carried out faster, more effectively as well?
Sure, so as you mentioned, the pen, paper, the traditional multimeter method can take a long time depending on the complexity of the board. Now with the RevEng and with the System 8 Ultima software, it will take a fraction of the time, even for multi-layered PCBs. So depending on the complexity, it can take some hours or it can even take some days.
It's really impressive, Munib, but for those watching us today who are not familiar with schematics, would you be able to tell us a bit more on why schematics are important? What are schematics, why they are important, and in your experience, who do you think RevEng is for?
So that's a loaded question, so let me answer it. So just like the Boardmaster, the RevEng is an invaluable tool for many different organizations across the world, whether that's the defense sector, aerospace, automotive, renewable energy, rail transport and so on, just to name a few. And it allows personnel, whether that's technicians, engineers, management, to create their own in-house labs. Now what we find is OEMs, they offer support only for a certain amount of time, and sometimes they remove the support earlier than expected. And for these types of sectors, for example the defense, they expect their equipment, their assets to run for a long time, for many years. And when the support has been removed, then what do? They'll have to rely on third parties and other people. So companies, different organizations, they bring their own facilities in-house, they create their own labs, and with the help of the boardmaster, with the help of the RevEng, they create their own laboratories to regenerate the schematics, repair documentation, fault find and diagnose issues on PCBs. Also, in addition to that, they can also find weaknesses as well, which will also help them improve PCBs in some cases as well.
It sounds very interesting and very impressive, Munib. I think with RevEng, as you're saying here, we are helping organizations bring the matters into their own hands, developing in-house capabilities to keep assets going for as long as possible, reducing e-waste, would you say, as well?
100%. So the RevEng is enabling organizations like the UK MOD, the US military, many rail organizations who are fully embracing the repair don't waste movement and reducing e-waste as well as costs.
Excellent introduction to RevEng, Munib. Well done. And this is all that we have time for today. In the next episode, Munib is going to help us understand how the user interface works, how the software works, the steps that you would have to go through in order to generate the netlist and the schematic from a good known PCB.